All right, so yesterday we learned two new postulates to prove triangles congruent. Anybody remember those two? Side, 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 and side, angle, side. And today we're learning two more. We got postulate 21, angle, side, angle, or ASA congruence postulate. It says if two angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. So, just like it says, angle, side, angle, the side is trapped in between the two angles, right? So you got an angle here, then a side, and then an angle congruent to an angle, a side, and an angle, all of them attached. And then theorem 4.5 is angle, angle, side, congruence theorem. Says if two angles and a non-included side of one triangle are congruent to two angles and the corresponding non-included side of the second triangle, then the two triangles are congruent. Right? So this time it's two angles and a side that's not in between the angles, but you have to make sure that the sides are actually corresponding. Right? So I couldn't have angle A and angle C congruent to angle D and F, and then side B congruent to side E, right? It has to be corresponding sides. So, moving on from there, looking at these triangle figures, we want to determine if it is possible to prove the triangles are congruent, and if so, which postulate or theorem is it? So we want to decide, is it possible by side, 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 angle, or angle, angle, side. So we got four options now, right? So the first set of triangles there, we have two angles marked congruent and two angles marked congruent. So, does anybody see a way that those two triangles could be congruent to each other? And we do have the option that we would have vertical angles here in the middle, right? But even if we show those are congruent, since they're vertical angles, now we've got three angles congruent. But so far, we haven't learned an angle, angle, angle postulate, right? Got to have at least one side, and we have no sides, and really there's no way to come up with saying that any sides are congruent to each other. So for this one, the answer would be no, we can't prove those congruent. All right, so then the next one, figure HIJK, got split down the middle to make two triangles. And we've got angle IHJ marked congruent to angle KJH, and angle KHJ congruent to IJH. So we got two angles. Anything else that we could come up with that would be congruent? Right, this side that splits the two triangles, it's shared by the two triangles, right? So it would be congruent to itself. And so now we've got an angle, a side, and an angle, congruent to an angle, side, and an angle. So we've got a side included between the two angles. So this one's going to be yes. And which postulate? Anybody? Angle, side, angle. ASA. All right, so then this next one, we got two triangles attached again. We got angle GJH marked congruent to angle IJH. And once again, since they're sharing a side, we could say that JH is congruent to itself. And so now we got one angle and one side. We would need another side or another angle, right? Anybody see anything that would tell us that any of the sides or any of the other angles would be congruent? Really don't have anything that would guide us to saying that anything else is congruent. So this one is a no again. All right. So this next one, once again, two triangles that are connected. We got nothing marked congruent though, right? So we got to figure out, is there enough information to prove that anything's congruent? But since they're attached, we should kind of catch the trend here, right? Attached, they share that side, they share that side, they share this side. So the shared side is always going to be congruent to itself. So that gives us one side. Now, anybody know what these little arrows mean? Right, so when we have two segments that have matching arrows on them, that means that those two segments or those two lines are parallel. Right? So these arrows are saying that segment UW is parallel to segment ZX, and segment UZ at the top is parallel to WX. Right? One arrow with one arrow, two arrows with two arrows. So the number of arrows match up, so that tells us that those are parallel. And so since those are parallel, then that gives us information about these angles 1, 2, 3, and 4. Because if we have parallel lines, then WZ becomes a transversal. Right? We look at it as a transversal with parallel lines, kind of like what we learned in chapter 3. And we have special relationships with those angles when we got parallel lines. Right? So angle 1 and angle 3, those are on different sides of the transversal and in between the two lines. So that makes them alternate interior angles. And if we remember back to chapter 3, the alternate interior angles are going to be congruent if the lines are parallel that are cut by the transversal. So that means that angle 1 and angle 3 are congruent to each other. And then angles 2 and 4, we have to compare those with lines UW and ZX being parallel. And once again, if we're using UW and ZX as our parallel lines, then 2 and 4 are going to be alternate interior angles between those two lines. And alternate interior angles are congruent again. So 4 and 2 would be congruent. And so now we've got an angle, a side, and an angle congruent to an angle, side, and an angle. So yes, and it's by angle, side, angle. All right, so then we got one proof in these notes. These are actually pretty short notes today. So we're given angle B is congruent to angle C, angle D is congruent to angle F, and then M is the midpoint of segment DF. So start our proofs with the given. So angle B congruent to angle C, angle D congruent to angle F. So and I've already got those marked for us. Angle B and angle C are congruent. Angle D and angle F are congruent. And then we can't really do anything else there that would be beneficial. We could say that angle BMD and angle CMF are going to be congruent because those of the third angles theorem. Remember, if you got two congruent angles, then the third ones have to be. But at this point, having three angles congruent doesn't prove that triangles are congruent. Right? So that wouldn't be a beneficial move. So I'm going to go ahead and bring in the other part of the given. M is the midpoint. Of segment DF. And with M being the midpoint, what's the benefit of them telling us it's the midpoint? Anybody know? If M is the midpoint of D and F, then we know the definition of midpoint. It says it's the point that divides a segment into two congruent segments, right? So if M is the midpoint, then the two segments, DM and FM, would have to be congruent segments. So since that's the midpoint, we can say segment DM is going to be congruent to segment FM. And that's based on the definition of midpoint. Since that definition says that it's a point that divides a segment into two congruent segments. That's how we know those two segments are congruent. And now if we look at what we got, we have an angle, and a side, congruent to an angle, and a side. So, is that enough to prove the triangle is congruent yet? It is, right? So, triangle BDM would be congruent to triangle CFM. And what congruence postulate are we using here? This one is angle side, AAS. Right? Because the side is not included in between the angles, it's outside of them, and it's corresponding. Right? So it wouldn't have worked if we had DM congruent to CM because those wouldn't be corresponding sides, right? All right, so that finishes those notes. Pretty short and sweet today.